Hello, ladies and gentlemen. Today we're going to be talking about how to convert between the two main forms of a quadratic. So we learned the other day about standard form, vertex form, and the factored form of a quadratic. The factored form we actually already know how to get to just by factoring a quadratic. You get there, right? But converting between vertex form and standard form is something that we may be asked to do, and we need to know how to do it. Luckily, we actually already have the tools to do both of these things, okay? First one, we're going to start with the easy one. This is if you have vertex form and you want to make it look like standard form. And some of you may have already done this and kind of already know what to do, but basically you just hit the FOIL. If you know how to FOIL, you can do this. So I gave an example here. You start with your vertex form equation. It's a little typo here. It should say vertex form. But we have 3 parentheses x plus 2 squared plus 1. We then go ahead and we FOIL out the x plus 2. So I wrote it out as x plus 2 times x plus 2. FOIL that, distribute, simplify anything you have to do, and you'll end up with a standard form quadratic, okay? So that's kind of the easiest thing to do is go from vertex form to standard form. Basically, it's FOILing it out, and then you're good to go, okay? Let's do one example together just to make sure that we're all on the same page. So once again, what I'm going to do is I'm going to write this out as 4 times x plus 5 times x plus 5. And then we have our minus 6 over here. And then I'm going to go ahead and I'm going to FOIL this. I'm going to do first, outer, inner, and last. Okay, and what you should notice is, again, that this is a factor pattern, so it's kind of always going to be the same thing. It's that perfect squared trinomial. But we're going to get x squared plus 10x plus 25. And then minus 6. And then we'll go ahead, we'll distribute this 4, and then we'll do some simplifying. So your final answer is going to be that you're going to get 4x squared plus 40x. And then 4 times 25 is 100, minus 6 will be plus, oh, there should be an x there, plus, it's a terrible looking x, all right, plus 94. Okay, and there's your answer. We just turned this from vertex form into standard form. Why don't you guys go ahead and try this one, FOIL this out, simplify it, and see if you can write this in standard form. Pause the video, try that, come back, and check with me. All right, so this is what I got. I went ahead and FOILed this out. I got x squared plus 2x plus 1. I then distributed the negative 2 through, and then combined the 4 and the negative 2 I would have got from there. And that's how I got negative 2x minus 4x plus 2. Again, if you can FOIL, you can convert from vertex form to standard form. Now we kind of get to where it gets a little bit more complicated. Okay, what if I want to convert from standard to vertex? I'm going to go from standard form to vertex form. And this is where we're basically just going to do completing the square, a process that we did maybe a little bit ago, but we kind of already know the whole process, and we just do it to convert to vertex form and not really to solve anything. So basically some of the big differences that you're going to see, it's going to be the same exact kind of steps that we're going to do. The only thing is that now you're going to have that y or that f of x, whatever we're calling it, is just going to kind of sit there the whole time, okay? So first of all, let's say I have y equals x squared plus 6x minus 7. I want to convert this into vertex form. The first thing I'm going to do, I'm still going to move that negative 7 over and get it out of the way. Okay? So just like I did before, move it over, get it out of the way, have it not be over there anymore. Next thing I'm going to do is I'm going to take that linear term, the b term, divided by 2, square it, just like we did completing the square. So off to the side, 6 divided by 2 is 3, 3 squared is 9. Add that to both sides, again, just like we did completing the square. Before, when we did completing the square and we were solving for roots, this would have just been a 16 over here because we would have put 0 in for y. When we're converting over to this vertex form, the y just sits there. It just hangs out. Okay? Then we go ahead and we factor that right side. Again, just like we did with completing the square. You already know whatever that coefficient was divided by 2, that's what it's going to be. So we know that it's going to be y plus 16 equals x plus 3 squared. And then we go ahead and we move that number back over, and now we're in vertex form, okay? Basically the exact same steps you did before when you did completing the square, just instead of this y being a 0, the y is just going to kind of hang out the whole time, so you get a final answer that looks like vertex form. Let's take a look at what this looks like and do it all together. So I'm going to start by moving the 5 over. We'll subtract 5, get you out of there. We're going to get y minus 5 equals x squared minus 8x. We're then going to go ahead and we're going to take that b term, in this case the negative 8. We'll divide it by 2, and we'll square it off to the side. So let's see, that's going to be negative 4. Negative 4 squared is 16. So I'm going to add 16 to both sides of my equation. So we'll add 16, add 16. So we'll get y plus 11 equals x squared minus 8x plus 16. We'll then go ahead and factor this side over here. So we'll get y plus 11 equals x minus 4 squared. And again, I know where that negative 4, I know what that is because it's whatever this number was over here. That's always going to be what you factor there. And then we'll subtract 11 to move it back over so that we get that y equals x minus 4 squared minus 11. And there's our answer. Okay? So that's how we're going to use completing the square to convert to vertex form. All right, so that's going to be what we do for today. Thank you all for watching.